So this course I have created for other students, okay, for other AML. For AML I created this course, okay. So anyways I will start with this content, okay. So now here, so this is it is structured in 4 phases, okay. So this course I have structured in 4 phases, okay. One is the foundation, okay, your networking basics, and then protocols and threats, defense tools, and compliance frameworks, and then advanced hands-on lab. And then we'll emphasize that every concept will be reinforced with the practical labs, okay, using tools like Wireshark and Cisco Packet Tracer. So this will help you to understand the cyber security concepts as well, okay. So this is how we will be doing it. Week 1, week 2, week 3, week 4, okay. After that you can learn all these concepts, okay. So this again in weak phase, this will not apply here, okay. So most of this topics we have covered. So wherever I feel that we need to cover this, then I will cover these topics, okay. So mostly we have covered TCP IP stack, OSI model, then IP addressing, and then SSH, and then HTTP, DNS, DHCP. Defense and compliance we have not covered, okay. So we'll see the phase 3 and phase 4. Phase 2 will see common threats, then we'll move on, okay. So in this model, we have covered these models, right, Shrutik? Earlier we have covered, I think, this one, OSA model, but however we will have an overview here. Okay. See, these visually compares 7-layer, okay, OSA model with 4-layer TCP IP model, okay. So this will be side by side comparison, okay. Each OSI is colored with different colors from layer 7, okay. So application purple, okay, down to layer 1, okay, green, okay. So the TCP IP model will be displayed as a grouped bands, okay, that map to OSI layers. So what is open OSI is open system interconnection, okay. So this model is a conceptual framework, okay, standardized by ISO. You have ISO standards, right? It was standardized by ISO. It breaks the network communication into 7 discrete layers, okay, so that different vendors equipment and software can interoperate. While the model itself is theoretical, okay, its layer numbering and terminology are universally um, used in networking, documentation and troubleshooting, okay. So they will network they will call, okay, layer 3 switch, okay, layer 2 switch means it will have the Ethernet and MAC. Layer 2 means it will be routing, okay, mostly on the core part, So they use the same terminology. Okay. So this layer 7, we'll see from layer 7, this is where the application interact with the network protocols like HTTP, FTP, SMTP, DNS, DHCP. This is the layer where you interact every day. Okay. The application layer, this is where you interact. Okay. The layer 6, okay, this is responsible for data formatting, encryption, compression, SSL, TLS, everything it will operate here. Okay. Conceptually, it will operate here and translate the data formats. All the formatting will be done here at the presentation. Session manages the connection between the applications. So I have given you this IRCTC example, how the IRCTC will work. Okay. This will handle coordination and termination, all that, how much time you need to give it to particular user. Based on that, your session will be connected or it will be terminated. So now it is a transport layer. Okay, this is end-to-end connection. Okay, end-to-end communication. Okay, so error recovery and then flow control, or this will provide a reliable delivery. Okay, so here you have UDP and TCP. UDP also, it will be very fast. It is connectionless delivery. Okay, this is connection state. This is not a connection oriented. So this we have covered already, TCP and UDP. And then we will come to network part. So this is responsible for logical addressing. Okay, logical addressing is your IP. Okay, and then routing, and then all the routers operate here. So whenever you ping ICMP or ping routing protocols live at this area, layer 3. Okay, and layer 2 is your low level. Okay, provides this one will give you node to node access. Like whenever you connect one computer to the other computer, this is where you will connect. Okay, it will provide node to node data transfer. Okay, and MAC address operate here. So you will be using your MAC address and then you will operate here. Switches, bridges, and address resolution protocol, ARP. Okay, functions at this layer. Okay. And then your physical layer where cables, hubs, actual hardware. This is the actual hardware where you will connect, whether it is Wi-Fi signals, whether your voltage, signal transmission, all this will work at this layer 1 and 2. Okay, for network access. So now you have IP addressing. So this is the private IP addressing range. Okay, 192.168.1.100. Okay. So this will break you the anatomy of 1.100. So let's say you have 1.100 network. This is a 32-bit number written in dotted decimal. Okay, this is a 32-bit address. Okay, so all will be dotted decimal notation as 4 octets, 1, 2, 3, 4. Hexadecimal will have a separate IP addressing range. Okay, so every decimal will come from 0 to 255. Okay, so like 1.1.1.1, okay, then 1.0.0.1 2, like that it will go to up to 255. Okay, so this range we call this as CIDR. Okay, prefix with CIDR. Okay, 64 bit we will identify the network, and remaining 8 bits identify the host. Okay, so this will be your network part and this will be your host part. Okay, so let's say in this example 192.168.1, okay, that is the network portion, so that is colored in blue. Okay, and the last octet 100 is your host address. This is your IP address of the host. Okay, and your subnet mask will be 255.255.255. Okay, wherever you have kept blue, that it will become your mask here. Okay, so our current mask, okay, here you have class C. This IP address is class C IP address 192.223. Okay, so you will have 254 IP addresses in each class. Okay, so first one you will have around in class A you will have around 16 million IP addresses for one range. Then in class B you will have 65,000 IP addresses, 65,534 I guess. Then class C you will have 254 computers. So this I hope you have done this in your graduation, right? These IP addresses. Okay, we will move to the different one. Okay, next slide. So this we have already covered the HTTP, HTTPS, then DNS, DHCP, all we have covered. Okay. So whenever client sends, let's say in hypertext transfer protocol HTTP, okay, this is the foundation for of data exchange on the web. Okay, when you visit any website, okay, your browser is acting like a HTTP client. Okay, it will be acting like a HTTP client, and the web server is a HTTP server. Okay, so HTTP is a stateless, okay, request response protocol. Each request is independent. Okay, it is not. This is not recorded. The client sends, okay, either get or post message. Get means I want the information. Okay, I want to retrieve the data. Post means you are requesting. Okay, I am submitting data. You give me that data. Okay, if you submit any form, then you are posting something data. Okay, put means you have something called put. Okay, which will update the data, and then we have something called delete. Okay, which will delete the data. Okay. So then server will respond with status code either 200 or 301 or 401 or 500. So that depends. Okay, status code 200 is okay. I am going to give you the information that you are asking. 301 will be, it will be simply redirect. Okay, you go there, you collect the data. 404 means not found. So whatever information you are looking, it is not found. 500 means server error. Okay, there is a problem with server, I cannot give you. Okay. 403 means forbidden. Okay, you are not supposed to access that. So those are all the server response status codes. Then you have something called HTTPS here, okay, which will add TLS encryption, okay, on top of HTTP, okay, protecting data in transit. Okay, whenever you put HTTP, your username and password, it will go in plain text. A hacker can see your username and passwords, okay, or whoever sitting in router, they can see your username and password. Okay. So if if your website is using HTTPS, all the HTTPS data will be encrypted. Okay. If you want, you can capture it HTTP, and you can see that passwords in Wireshark. Okay, that is about the HTTP. Yes. Now we have something called DNS. DNS is a application layer. This is all about the application layer. Okay. Like it will be translating your host name to IP addresses. Okay. DNS acts as a internet phone book. Okay. It translates human readable domains like google.com or rediff.com into IP address that computer will understand that. That is the difference between DNS, how DNS will work. DNS will work on port 53, whereas HTTP will work on port 80 and HTTPS on 443. Okay. Now you have a DNS query. Okay. So DNS query flow. Okay. First you will send a request. Okay. Let me put up a request here. DNS lookup www.google.com. Okay. This I am putting the request. So it will check with the local cache, okay, whether we have any local cache here, means locally any configured name, then recursive resolver. Significantly timed out. Okay, I will put my IP address. It's not at all resolving. Okay. So you will have this resolution. If you type NS lookup and host name, it will resolve to IP address. Okay. And if you put IP address, then it will resolve to DNS name. So DNS operates over UDP port 53 for queries. Okay. So now we have something called DHCP. This one also I have covered, the DHCP. DORA process. Discover, offer, request and acknowledge. I will skip this topic. Then we have protocols SSH and TLS. Okay. So these are two security focused sorry these are two security focused protocols, okay, that will protect the data in transit. Okay, whenever your data is getting transferred or transit, then your data will be protected through um, encryption. Okay, so it will be secure remote access, and TLS are among the most commonly used protocols in our realistic scenarios or in security work. So only this methodology uh, big organization will allow to copy the data. Without this, they will not allow the data to get copied. Okay. Now you have SSH. Okay. SSH will operate on port 22. Okay. So it will provide a encrypted command line access to the remote servers. I hope you have access to Fedora servers or Fedora workstation using PuTTY shell. Okay, when you connect to that PuTTY on that IP address and port 22, it will give you the prompt. Okay, so you will type usernames and then you will type the password, or you can use the public key authentication without any password. Okay, with cryptographic key pair. Okay. It is very secure than the passwords. Now you have authentication methods. How you are authenticating the methods? Whether you put password or public or private key, then it will allow you for accessing the SSH. So Ritik, can you connect to any of the Linux machine?